Hey everybody, it's the Jazz Architect. Today, I want to talk about something we hear all the time when people discuss artificial intelligence. We say that AI learns. We say that a model has been trained. We even talk about machine learning. But what exactly does that mean? When a human being learns something, we have some understanding of what is happening. You read a book, practice a skill, make mistakes, remember experiences, and hopefully become better at something over time. But when we say that a computer learns, we are talking about something very different. So today, our central question is, when we say AI learns, what does that actually mean? Let's start with something called a neural network. The name can be a little misleading because it sounds like we are saying the computer has a brain. It does not. Neural networks were loosely inspired by ideas about connections between neurons. But an artificial neuron network is fundamentally a mathematical system. Imagine thousands, millions, or even billions of mathematical connections. Information enters the system, calculations take place across those connections, and an output is produced. During training, the system continually adjusts the numerical values, controlling those connections so that its predictions become better. Those numerical values are what we call weights. Think of a weight as a tiny influence control. One piece of information may need to have a stronger influence on what happens next, while another piece may need to have less influence. During training, the system gradually adjusts these weights. I sometimes think of them as millions or billions of tiny volume knobs. Imagine sitting in front of the largest mixing board you've ever seen. Every knob influences something else. And during training, those knobs are being adjusted over and over again. Now, obviously, AI does not have somebody sitting there manually turning billions of knobs. Mathematics does the adjustments. But that image can help us understand what a weight does. So how does the system know which direction to turn those knobs? This is where training becomes very interesting. Imagine I show an AI system thousands of examples and ask it to make predictions. At the beginning, its predictions may be terrible. It makes a prediction, compares that prediction with the desired result, calculates how wrong it was, and then makes very small adjustments. Then it tries all over again, gives a prediction. Oops! Error. It makes an adjustment. Another prediction. Error again. Makes another adjustment. This can happen over and over across enormous amounts of data. There is a mathematical measurement of error often called the loss. The training process is trying to reduce that loss. In simple terms, the model is asking mathematically, how wrong was I? And what small changes would make me less wrong the next time? One important technique involved in this is called backpropagation. That is a big word for an idea we can explain fairly simply. After the model produces an error, the system works backwards through the network to determine which connections contributed to that error and how those weights should be adjusted. There is another term called gradient descent. Again, the mathematics can become very complicated, but the public does not necessarily need the equation to understand the concept. Imagine standing somewhere on a mountain in heavy fog and trying to find the lowest point in the valley. You cannot see the entire mountain, but you can determine which direction slopes downward. So you take a small step, then you check again. Another small step. Training a neural network works somewhat like that. The system is repeatedly making mathematical adjustments intended to move towards a lower error. And that brings us back to our question. When we say AI learns, what does that actually mean? It does not mean the machine sat in a classroom and suddenly understood the subject the way a student might. It means that through training, enormous numbers of numerical parameters were adjusted so the model became better in recognizing patterns and making predictions. A parameter is one of the learned numerical values inside the model. Weights make up a large portion of those parameters. So when you hear people say a model contains billions of parameters, they're talking about an enormous collection of learned numerical relationships. Now let's connect this to language models. A large language model is trained on enormous amounts of text. During training, one of its fundamental tasks is learning to predict what comes next. Imagine the sentence, "The piano player sat down at the..." You might predict piano, or maybe keyboard. You probably would not predict refrigerator. Why? Because your experience with language tells you that some words are more likely than others given the context. A language model learns statistical patterns in a much more complicated way across enormous amounts of text. It develops relationships among words, pieces of words, concepts, grammatical structures, styles, contexts, and patterns. The pieces of language that models process are often called tokens. A token might be a whole word, part of a word, punctuation, or another small unit of text. The model processes those tokens and calculates probabilities about what token should come next. But here's where people sometimes underestimate what is happening. If all the model did was predict the next word using a simple list, it would not be very impressive. What makes modern language models powerful is that they learn extremely complex relationships across contexts. To predict what comes next well, the model has to capture patterns involving grammar, subject matter, relationships between ideas, writing styles, reasoning patterns, and much more. That does not mean it understands those things exactly as a human being does. That distinction is extremely important. AI learning is not human learning. A model does not have your childhood, your family, your body, your fears, your ambitions, your cultural experiences, or decades of lived experience. It does not sit at the piano for 6 hours practicing a passage while getting frustrated because the left hand still will not cooperate. At least it does not complain about practicing scales yet. And this is where jazz gives us an interesting analogy. When I was learning to improvise, I listened to great musicians. I practiced phrases. I studied harmony. I made mistakes. I played with other musicians. Over years, all of those experiences influenced what I might choose to play during a solo. If someone asked me exactly where every note in an improvised solo came from, I could not point to one record or one lesson and say that note came from there. My musical language developed through thousands of relationships and experiences. There is a useful analogy here with AI, but we have to be careful. A neural network is not jazz. It's not math. It's not science. It's a mathematical training unit. It's not a human experience. But the analogy helps us understand one important idea. Learning patterns is different from storing a giant collection of finished answers. A language model does not simply contain a filing cabinet with every possible question and answer inside. Its training changes the relationships among enormous numbers and numerical parameters. Then, when we give it a prompt, it uses those learned relationships to generate a response. That is also one reason AI can create responses it has never produced before. And it is one reason AI can make mistakes. This is extremely important for the public to understand. AI has learned patterns that allow it to generate highly convincing language. But convincing language and guaranteed truth are not the same thing. The model is generating based on patterns, probabilities, context, and instructions it has been given. That means an answer can sound beautifully written, confident, and completely reasonable while still containing an error. We sometimes call fabricated or unsupported information from an AI system a hallucination. Remember that word? We talked about that a few episodes ago. I actually think understanding training helps explain why hallucinations happen. If you believe AI is simply retrieving facts from a giant encyclopedia, then a hallucination seems bizarre. You might ask, why didn't it just look up the correct answer? But once you understand that a language model is generating responses from learned patterns, the possibility of an incorrect but plausible response makes more sense. This is why human judgment remains so important. And there's another distinction I think everyone should understand. Training is different from using the model. When you open an AI application and it asks it a question, the massive training process has generally already occurred. Your conversation is not the same thing as rebuilding all of the model's underlying weights in real time. The model takes your prompt and uses what it learned during training to generate a response. Different AI products can have memory systems, personalizations, additional training, tools, or other ways of adapting, but that is different from the original large-scale training process. So again, when we say AI learns, what does that actually mean? It means mathematics, data, prediction, error, adjustments, and repetition. It means weights being changed. It means patterns becoming encoded across enormous numbers of parameters. And it means a system gradually becoming better at producing useful predictions without someone manually programming every possible answer. For me, this is one of the most important concepts for the general public to understand because it removes some of the mystery surrounding AI. Artificial intelligence can look magical when you type one sentence and receive a sophisticated response seconds later. But underneath the experience is mathematics. There are neural networks. There are weights. There are parameters. There are training data. There were predictions. There were errors. And there were enormous numbers of adjustments. Understanding this also changes the questions we should ask about AI. Instead of only asking, what can this system do? We can also ask, how was it trained? What kinds of patterns did it learn? Where might those patterns be incomplete? What information should I verify? And where does human judgment still need to enter the process? Those questions become especially important as AI enters education, business, medicine, music, science, and everyday life. And perhaps this is the most important takeaway from today. AI learning is incredibly powerful, but it is not magic. It is not identical to human learning. The more we understand the difference, the better prepared we become to use these systems intelligently. Because once we understood how the tool learns, we can make better decisions about how we teach with it, how we work with it, and when we should question what it gives us. So the next time somebody tells you that an AI system has learned, ask one more very important question. What exactly do we mean by learning? That question opens the door to understanding, neural networks, weights, parameters, training, prediction, and ultimately what modern artificial intelligence actually is. Okay, that brings us to a close of another podcast. Keep your eyes and ears open, stay kind, and keep being a groovy person. And remember, being creative and innovative is the best way to start and end your day. I'm Richard D. Johnson, the Jazz Architect. I'll see you next time.